All right, lesson 11.2, slope of a line. First of all, for homework, you just need to watch this video and fill out the note packet as you go through the video. Make sure that you come to class tomorrow with notes already completed and any questions you may have about this lesson. All right, this term refers to the slant of a line. The ratio is also referred to as rise over run. It's often written as a fraction with rise being on the numerator and run the denominator. And sometimes you may even see it as the change in y over the change in x. Remember that M stands for slope. So slope is the slant of a line. That's what we're talking about. All right, if you know any 2 points on a line or 2 solutions to a linear equation, you can find the slope of the line without even graphing. We're going to use this formula for slope. Slope equals y2 minus y1 over x2 minus x1. And those x1s and y1s, those are the points. Those are the x and y coordinates of the 2 different points. So let's give it a try. All right, first off, I want you to find the slope given the 2 points, -5, 8, and 3, -4. So remember, we need to use that y2 minus y1 over x2 minus x1. So the -5 is actually x1. It might help you if you label it like that on your notes. And 8 is y1. And then the second ordered pair, 3 is x2 and -4 is y2. So when we use that formula, I actually have -4 minus 8 divided by or over 3 minus a -5. You see how I went ahead and put that in a parenthesis. Now we've talked several times about substituting in for a variable and how important it is to put that number in a parenthesis, and right here is proof as to why that's important. Okay, so -4 minus 8. Well, if you if you need to chum, you see that that's the same thing as -4 plus a -8, which equals -12. And then 3 minus a -5 is the same thing as 3 plus 5, which equals 8. But we're not finished yet because this is actually a fraction and we can reduce. So when we reduce this fraction, we actually end up with -3 over 2. Okay, let's try the next one. So here I want you to find the slope given the points -4, 2 and the point 8, 0. All right, so again, you may want to label that first coordinate as x1, y1 and the second one as x2, y2. When we use the formula m equals y2 minus y1 over x2 minus x1, we have 0 minus 2 over 8 minus, and then in parentheses, a -4. Let's see, 0 minus 2 is just -2. 8 plus 4 is 12. And again, remember, we need to reduce. This is a fraction, so that reduces down to -1/6. Okay. Example C. Same thing. Find the slope given 2 points. I have the point -6, 4 and the point 2, -5. Okay. So again, -5 minus 4 over 2 minus a -6. Hopefully you're pausing as you go through this video And instead of just zooming through so you can see what the actual solutions are, maybe you're pausing and trying to do a couple of these examples yourself. Okay? So I really have negative 9 over 8, and that can't be reduced. That is as simplified as it can possibly get. All right. We can also find the slope of a line from a graph. Okay? So we can look at a graph and identify the slope of the line. And how we do that is we look at the points from left to right, just like we read a book. So the first point that I see to the farmost left is the point 0, 3. And we just decide, we look at that point and we read it from left to right. So to go from the point 0, 3 to the point 4, 1, remember I do the rise first. That's the up and down function. So I actually, when I do the up and down function, I'm actually going down 1, 2, and then to the right 1, 2, 3, 4. So when I look at that from a slope standpoint, down is negative, so that's the same thing as negative 2 over 4, which reduces to negative 1/2. Let's try that again with a different one. All right, on this one, I have no points marked, but I can clearly see where it crosses the x-axis and where it crosses the y-axis. So I'll make those be my 2 focus points. All right, so I'm going to start where it crosses the y-axis. So I'm going to count my downward. 1, 2, 3, 4, 5, 6. So it's down 6 and over 1, 2, 3, 4. So down is negative, so that's the same thing as negative 6, and then to the right, positive 4. And negative 6 over 4 reduces to negative 3/2. Okay, so those first 2 graphs have negative slope, and you can see that the line, as you look at it from left to right, actually slants downward. All right, this line, different from the last 2, actually, when you look at it from left to right, slants upward. So this one is probably going to have positive slope, but let's check. So again, when I look at 2 points, I have the point right here where I cross the y-axis, and then I have the point 1, 1. Those are very clearly defined points. So let's see, to go from where I cross the y-axis, or sorry, where I cross the x-axis at negative 3, 0 up to the point 1, 1, I'm going to go up, which is a positive, up 1, and then it looks like I'm going to go over 1, 2, 3, 4. So that looks like my slope is going to be rise of 1 over a run of 4. Okay? Let's look at this last one. This is a little tricky. Okay, so I can pick any of these points. So let's say I start from here to here and I go up. It looks like I'm going to go up 4, but I don't ever go to the right. There is no run. I'm not going to the right or to the left. I'm not moving horizontally at all. So that bottom number is 0. And remember, whenever we have 0 in the denominator, the answer is undefined. So that means that all vertical lines have undefined slope. What do you think the slope of a horizontal line is? We'll have to talk about that. All right. In this next example, I want you to know that parallel lines have the same slope. So I want to prove that to you. I have a line with 2 points, 0, 5, and 6, negative 2, and then my second line has the points negative 1, 3, and 5, negative 4. And all that means is that the line passes through these points. So I want to prove to you that these 2 lines are parallel, and the only way to prove that to you really is to find the slope of each one of those lines. So I'm going to use that formula that we used in our first 3 examples, y2 minus y1 over x2 minus x1. So I'm just going to find the slope of line 1. So the slope for line 1 is negative 2 minus 5 over 6 minus 7 over 6. That is the slope of line 1. I'm going to use that same formula and find the slope of line 2. So I should have negative 4 minus 3 over 5 minus a negative 1. Negative 4 minus 3 is negative 7. Negative 5 minus 1 is the same thing as 5 plus 1, which is 6. So again, hopefully you can see that I have this same slope. The slope for line 1 is negative 7 over 6, and the slope for line 2 is negative 7 over 6. So these two lines are parallel. We also know that perpendicular lines have a negative reciprocal slope. So let's see, reciprocal means that we take the fraction and we flip it, and negative means that we just use the opposite sign. So really it's going to be the opposite sign. Okay, so let's talk about these two lines. The first line has the points negative 6, 4 and 2, negative 5. And the second line has the points negative 1, negative 4 and 8, 4. So again, I'm going to use the formula y2 minus y1 over x2 minus x1 to determine my slope. And let's calculate the slope of line 1 first. So when I calculate the slope of line 1, I have negative 5 minus 4 over 2 minus a negative 6. And that comes out to negative 9 over 8. So line 2's slope, I have 4 minus a negative 4 and 8 minus a negative 1. So that really is the same thing as 4 plus 4, which is 8, and 8 plus 1, which is 9. So when I look at this, I see that I have the reciprocal. I went from negative 9 over 8 to 8 over 9, so I've reciprocated that fraction. And also I've changed the sign. The first slope of the first fraction is negative. The slope of the first line is negative. And the slope of the second line is positive. So I have, in fact, used the negative or opposite reciprocals. Okay? All right. So we can also graph lines that pass through a point given the slope. So we can take a line and graph it if we are given the slope and a point, an ordered pair. So here we're given that we have this line passes through the point negative 5, 6. So I start at the origin and I move to the left 5 because it's negative, and then I need to go up 6. And then I have a slope of negative 3 over 2. This first number, negative 3, tells me if I'm going to move up or down. Since it's negative, I'm going to move down. So this point is actually going to move down 3. So I'm going to move down 1, 2, 3. And then I have a run of 2, and that's a positive, so that means that I'm going to move to the right 2. 1, 2. So now I have 2 definite points, and then I just connect them with a line. So I have graphed that line. All right, let's try our last example. Graph the line passing through the points negative 7, 7 with the slope of 5 thirds. Okay, so again, I'm going to start at the origin. I'm going to move to the left 7 and then down 7. There's my first point, negative 7, 7. And then I have a slope of 5 thirds. So that means my rise is a positive 5. So I'm going to move up 5. 1, 2, 3, 4, 5. And then I have a run of 3, and that's a positive 3. So I'm going to move to the right 3. So 1, 2, 3. All right. So now I have the point negative 7, 7 and the point negative 4, negative 2. I'm going to connect those with a line, And there again we have graphed a line given a point and slope.